Hi students, this is Alex here. In this video, we are going to find the Fourier series expansion of the function f of x in the range 0, 1. The value of 2L here is this 1. So from this, we can find L as 1 by 2. Now, the formula for Fourier series is f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L plus summation n equal to 1 to infinity bn sin n pi x by L. We got the value of L as 1 by 2. So we're going to replace that. So f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by half. When I put by half, and it will become into 2 because of the reciprocal, that is n pi x by half, and this will become n pi x into 2 by 1. So it is 2n pi x. Similarly, summation n is equal to 1 to infinity bn sin 2n pi x. Now as the first part, we are going to find a0. The formula is 1 by L integral 0 to 2L f of x dx. Now this is 1 by half integral 0 to 2 into half is 1, and f of x is x minus 1 whole square dx. Now this 2 will be taken to the numerator, so 2 integral 0 to 1 x minus 1 whole square dx, and this is 2 x minus 1 whole cube by 3, and we have a limit which is from 0 to 1. When I use the upper limit, it will become 1 minus 1 whole cube by 3, so which is 0, minus, when I use lower limit, 0 minus 1 whole cube by 3, and anyway the first term is 0, and minus, this is minus 1 whole cube is minus 1, so we can make this as plus. So finally this is 2 by 3. So thus we got the value of a0, which is 2 by 3. Now we continue to work out an. An by formula, it is 1 by L integral 0 to 2L f of x into cos n pi x by L dx. So this is 1 by half integral 0 to 1 f of x is x minus 1 whole square and cos n pi x by half, so it is 2n pi x then dx, and this we are going to rewrite. So 2 integral 0 to 1 x minus 1 whole square, and now it is cos 2n pi x dx. Now we are going to use Bernoulli's formula for integration. Integral uv dx is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. So now u, so an equal to, there is a 2 outside, we are going to write u v1. U is x minus 1 whole square. v1 is integration of this sin 2n pi x by 2n pi. We have to divide by the coefficient of x, minus u dash which is 2 into x minus 1, and integration of v1 will be minus cos 2n pi x by 2n pi, but already there is 2n pi, so it becomes 2n pi whole square. Now plus u double dash, which is the derivative of this term, and that will be 2 into minus 1, and v3's integration of this, that is again minus sine 2n pi x by 2n pi whole cube, and we have our limit from 0 to 1. When I substitute the upper limit 1 for x, this will become 0, this will become 0, and here when I put 1, we get sine 2n pi, that is also 0. So upper limit, all the values are 0, minus, when I put the lower limit, these two terms are sine terms, so sine 0 is 0. So the only term left is the middle term, which is minus 2 into 0 minus 1, and cos 0 will be 1, and there is a minus sign, so minus 1 by 2n pi whole square. So totally we get 2 into, we can cancel these two minus, and even these two minus, it will become plus. So 2 by, we will square this, so 4n square pi square. So this 2 into 2 is 4, we can cancel, we get 1 by n square pi square. So we got an, which is 1 by n square pi square. After this, we continue to calculate bn. So bn by formula 1 by L integral 0 to 2L f of x sin n pi x by L dx. Now L is half, integral 0 to 1, f of x is x minus 1 whole square, and this is sin n pi x by half, L is half. Again, we are going to rewrite this. So this is 2 integral 0 to 1 x minus 1 whole square sin 2n pi x dx. To integrate this, we are going to use Bernoulli's formula. We have u and v. The formula uv dx is uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. Now bn will be 2 bracket open u, which is x minus 1 whole square. v1 is minus cos 2n pi x by 2n pi. Now minus u dash, which is 2 into x minus 1, and v2 is integration of v1, which is minus sin 2n pi x by 2n pi whole square plus u double dash. U double dash is derivative of this without the minus sign, which is 2 into 1. Actually, when we do an, this is supposed to be plus because its derivative is 2 into 1. But anyway, this term becomes 0 in both the cases. Okay, now this integration is cos of 2n pi x by 2n pi whole cube. We have 0 to 1 as a limit. When I use upper limit 1, this will become 0, this will become 0. So 0, second term is 0, third term is 2, and cos 2n by is 1. So 2 by 2n pi whole cube minus, when I put lower limit, here when this is 0, 0 minus 1 whole, 0 minus 1 whole square is 1, and cos 0 is 1, but there is a minus sign, by 2n pi, and second term is 0 because of the sign, and the last term is plus 2 by 2n pi whole cube, and here we get bn equal to 2 into, this term is 2 by 2n pi whole cube, and when I carry this minus here, it will become plus 1 by 2n pi and minus 2 by 2n pi whole cube. So these two gets cancelled. Finally, we get bn as 2 by 2n pi, and we can cancel this. So bn becomes 1 by n pi. So now we come to our formula, which is f of x is equal to a naught by 2. A naught is 2 by 3. So when I divide 2 by 3 by 2, it is actually into 1 by 2. That is a naught by 2 plus summation n equal to 1 to infinity an. An is 1 by n square pi square. So 1 by n square pi square cos n pi x by L, after putting, that is n pi x by L, L is half, plus summation n equal to 1 to infinity bn, which is 1 by n pi sin n pi x by half. Now we can cancel these two. So 1 by 3 is our first term. 1 by pi square can be taken out from the summation. We have summation 1 to infinity cos n pi x by n square. Then here 1 by pi can be taken out, and actually there will be a 2 also. Cos 2 times of n pi x. Even here sin 2n pi x by n. Now in any case, when I expand, that is n is equal to 1 to infinity, whatever we put for this n, let's expand it. So now f of x equal to, this is 1 by 3 plus 1 by pi square. When n is 1, here it will become cos, or it is better to leave the expansion as it is, that is using the summation. This is from n is 1 to infinity cos 2n pi x by n square plus 1 by pi summation n is equal to 1 to infinity sin 2n pi x by n. This is our required Fourier series expansion for the given function f of x.